Welcome back to Byte Forever, and today we're on ZX81. We're just trying to find out if this 16K RAM pack is actually worth the money. Well, at least if it's working correctly. I mean, whether it's worth the money, even if it's working, again, that's questionable. But what I wanted to do is write a simple program which would show us if we could access the full 16K RAM. So I've been searching around on Google, and although there are some programs you can just basically poke memory, all the addresses up to that 16K, or actually it's not from 0 to 16K because of the way the memory maps in ZX81. You can run that program, and when I did that, it actually did just kind of hang for ages. So I think just because the way the program is written in BASIC as well, it just takes so long to run. I thought there must be a quicker way of checking that at least this thing's plugged in and the computer can access the top of memory. Anyway, so we've got this program which defines an array of length 3000, and 3000 in this case, in ZX81 arrays are all stored as floating point numbers. So you have, in the case of ZX81, it's an 8-bit exponent, and let me just check. Did have it on a website here. Yep, so it's 8 bits for exponent and 32 bits for mantissa. That's what a floating point number in this case is made up of, so that's 5 bytes. So if you try to define an array which is 3000 long, that should test the fact that we can access basically 15,000 bytes of memory, and this will or should work on a 16K machine. If it fails, then you should get the error /0. So anyway, it would or should fail straight away if you can't define that. But even better than that, we'll try right into that memory, and in this case, right into the last byte. Oh, sorry, the last index of it. Putting 99 in, and then on line 30 we're just going to print it out. So if we run that, goes away for a bit and prints 99 out. So that kind of proves, in one sense, we can access 16K. What it doesn't prove is that any one of the, I believe the DRAM chips make up the 16K RAM pack. It doesn't prove that one of those is faulty. To do that, you would have to basically write to and read from every one of those locations. So I'm going to just change this program, pause the video recording, and I'll be back in a minute. Okay, so what I've done is just rewrite this little bit of code, and again, so we've still got define the array 3000 long, and just fill in the whole array with the index of the for loop, and just spotted an error there because it's got next a and not next n. So one thing with this is with the ZX81 basic, you can edit it like this, so you can move this line pointer to where you want it. The shift and the 1 key, which is the edit key, and you can just use cursor keys then and rub out key and press it, and there you go. So I'll run this. It should go all the way through and then just print 3000 out. Not sure how long this is going to take, but here we go. So our screen goes blank because obviously it's just busy writing to memory. So hopefully this proves that you can write to all that memory and then at least read the last one. what I should do is again just change that so it reads every value and checks every value. Another thing you can do on the ZX81 to speed it up a little bit is to put this into fast mode. So in fast mode on ZX81, it's just another command, basic command, and it just causes the CPU to run the code without updating the screen. And because of the way the architecture of this computer is, the screen writing to screen memory actually takes up quite a lot of time. There's no, well, there is a ULA in there, but that doesn't actively write to the screen independently of the CPU. So anyway, what I'll do, this appears to still be running. I'll pause the video recording and maybe come back when we've got to the end of the program. I'm not sure how long that'll take. It could take all year. Okay, so actually it was only a few seconds after I paused the video and stopped rambling along that it has written to all the memory and read back the last value. So I think what we can do is just edit this again. I'll do it off camera, come back, and actually just read every memory location out, or sorry, every array location back out, and then just check that against the value put in. And obviously, if it's not equal, then it might as well be a doorstop and can't reliably read and write to memory. To be fair, up to now, with all these few tests I've been doing, it seems to be working okay. So off camera, I'll just edit this program to add those things. Okay, so just added a bit of code. Effectively, it's the same as before at the top. Line 30 now runs back through the array. If an is not equal to n, then print error, next n, and then line 50 prints end. So in theory we can run this, and again it's going to take quite a few minutes, but if at the end it just says end, then the memory, as far as we can tell by this test, has got no errors. So as before, I'll just pause the video recording and come back when this completes. Probably go for a brew. Okay, so it looks like that was a success. Just printed end. I just went and got a brew in a, what's this cup? Sequel Bits Disco. Pretty cool mug. Anyway, for a brew, that's probably only about 3 minutes, and it looks like it's printed out end with no errors. So I'm fairly convinced now that I've got some other problem when I'm trying to load bigger games or bigger files into the tape interface. It could just be, you know, there's some fault in that circuit, but then it does load the 1K chess and that breakout game. So I'm not really sure. I'm also not sure how to fix it yet if it is that. Probably come down to desolving some of the components, maybe checking the values of the, you know, are they intolerant or not? Is it a capacitor? Is it a dodgy diode? I mean, there isn't much in this computer anyway. You know, so it's fairly simple. It could still be the cable. Again, why would it work for some of the files?